Hi, welcome to this lesson on trigonometry, trigonometric functions part 2. Let's have a look at question 6. We're given f of x equals a times cos of bx, where x is between negative 180 degrees and positive 180 degrees. So we're given this graph and we can actually read off some values from the graph. At 0 degrees it's 3, at 180 degrees it's 0, and at negative 180 degrees it is also 0. Okay, so the first question asks us to write down the values of a and b. So first of all, we know some coordinates. Let's write them down. 0 degrees was 3, 180 degrees was 0, and negative 180 degrees was 0. Okay, so I can use that and substitute them in. So f at 0 degrees is 3, so this implies that a times the cos of b times 0 degrees equals 3. But b times 0 degrees is just 0 degrees, and cos of 0 degrees is 1. So a times 1 equals 3, so therefore a equals 3. Okay, so far we've got f of x equals 3 cos bx. So now let's take another point. Let's take 180 degrees and 0. So f at 180 degrees must be 0, so this implies that 3 times the cos of 180 degrees times b equals 0. So this is a trigonometric equation that we can solve. Okay, so if I divide both sides by 3, I get a cos of 180 degrees times b equals 0. And when is cos 0? So if you look at the standard cos graph, right, it's at 90 degrees or 270 degrees. Okay, and it'll keep repeating, so on and so forth. So the general solutions are the angle 180 degrees times b equals either 90 degrees plus k times 360, or 180 degrees times b equals 270 degrees plus k times 360. Okay, where k is an integer. But we want an actual value for b. So what I'm going to do is, so for the first solution here, I'm going to divide both sides by 180 degrees. So I get b equals 90 divided by 180 degrees, that is a half, plus k times 360 divided by 180 is just 2. And then for the second solution set, if I divide both sides by 180 degrees, 270 degrees divided by 180 degrees, what does that give us? 3 over 2, right, plus k times 2. All right, so how do I know which b value to take? All right, so for the first one here, if I put k equals 0, then I simply get b equals a half, and that value will work. Similarly, if you take any other k value for either one, so all of these would work. So I would just take the first easiest one, which is when k equals 0, b is a half. Okay, so the function that we have is f of x equals 3 cos of a half x. All right, write down the period of f. Okay, well, now that we know f of x equals a, which is 3 cos a half x, right, because b is a half. So the new period here will be 360 degrees, which is the cos period, divided by the b value of a half. So I get 720 degrees. That will be my new period for f. So every 720 degrees, you'll have a full cosine wave. For which values is x is a cos bx, which we know now is 3 cos a half x. When is that equal to 2? So if you go to your graph here, let's check. 2's over here, so we expect a solution here somewhere, and we expect a solution here somewhere. So it looks like it's just above 90, more than 90 degrees and less than negative 90 degrees. So let's go see if we can work those out. Okay, so I'll have cos of a half x equals 2 over 3. Okay, so bring my cos diagram out. Where's cos positive? First and fourth quadrants. And I need a reference angle. So my reference angle is going to be cos inverse of 2 over 3. That's 48.19 degrees. Okay, so now the angle, which is half x, so in the first quadrant, the angle half x must be equal to the reference angle 48.19 degrees plus k times 360 for the cos graph. And the fourth quadrant solution must be half x, the angle, equals 360 degrees minus this value, which gives you 311.81 degrees. Okay, plus k times 360. Okay, now to get rid of that half, I multiply both sides by 2. So if I do that, this will become 96.38 degrees plus k times 720. And 720, we worked out that was the period, so that makes sense. And the same thing, if you multiply this by 2, you get 623.62 degrees plus k times 720 degrees, where k is an integer here. Okay, but this is the restricted domain. So for the first one here, if I put k equals 0, I'm going to get x equals 96.38 degrees. And if we go up here, that looks like it's right. 96.38 degrees. Okay, so that's the x value for that one. So if we do any other k integers, it'll be values outside there. And then similarly here, k equals 0, that will not give you any applicable solution because you'll get 623.62 degrees. So I'm going to try k equals -1 because I feel like that might work. And if we put -1 for that, what are we going to get? Okay, so multiply by 2. That's the answer. So it's that answer minus 1 amount of 720. We get -96.38. Okay, and does that make sense? -96.38 degrees? Yes. Now, where does that number look familiar? It's literally the negative of that number. And that makes sense. Cos is an even function, so it's symmetrical about the y-axis. Okay, so once you found one, you could have easily found the other one. All right, so those are the two x values. That'll give you that y value of 2. Okay, so now you want to sketch the graph of g of x equals 1 plus sine of x minus 45 degrees on that same interval. And then it says, indicates where the points of intersection are located. So they're not asking you to find the points of intersection, but rather just indicate it on the graph. Where is it? Okay, so let's bring up our table here. So 1 plus sine of x minus 45 degrees. Okay, and you're starting from -180. We're going to 180, and the steps here were given in 45 degrees. Okay, so -180 degrees gives us 1.7071. So that's somewhere up here. 1.7071. Okay, and then -135 degrees gives us +1. So that's over here. And then we said at -180 degrees, it is somewhere up there. All right, then we're going to have -90 degrees being 0.2928, which is quite low. It's over here, 2928. So at -90 degrees, that's the y value. Okay, then at -45 degrees, it's 0. And then at 0 degrees, it's that same value. So there's your y-intercept. Okay, we've also got an x-intercept of -45 degrees, 0. Then 90 degrees gives us that 1 point value again. What was 45 degrees? 1. Okay, so 45 degrees was 1. 90 degrees was 1.7. Then we have 135 degrees gave us 2, which is up here. And then 180 degrees gives us back that value again. Okay, so if we draw this, it's going to look something like this. Okay, and then it's going to turn there. It's going to come back up. And it's going to go there. All right, so that's in fact one full sine wave, right? Because the b value here is 1. So the 360 degrees, so between -180 and 180, that's a full sine wave. Okay, so where are the points of intersection located? So one is located over here, and one is located over here. All right, so if we had to try approximate, this looks almost part way between 90 and 135. And then this one here looks like it's about 1/3 away from -135 and -180. Okay, so that's how we would do these types of questions. I'll see you in the next one.